Hey guys, welcome to our very first online video here. So this is our week 1 video 1 notes. So as I go along and I go through each of these examples, I highly suggest that you write down these examples with me in your notebooks, and then you'll have something to refer to when you go to do your week 1 video 1 homework. So let's get ourselves started. Today we're going to start chapter 7, which is trigonometric functions and acute angles. So the three sides of a right triangle are referred to as a hypotenuse and two legs. So the hypotenuse is always the part that is across from the 90. So this piece over here is my hypotenuse. Now, the other part are the two legs. So this is a leg and this is a leg. And we actually call these legs based on what angle that I'm looking at. So this angle right over here is theta. So it's got this little like O circle with a line through it. This is called theta. It is my reference angle, which means I'm going to be looking from this reference angle to the other two sides. So if I'm looking at this reference angle, if I go straight across from that angle, this side over here is called the opposite side, which makes sense, right? And then the other one is the one that's right next to theta, right over here. It's touching it. This is called the adjacent side, which I'm sure you probably remember from your geometry days. So for our first part here, we're going to be talking about some special right triangles and their relationships. So there are two special right triangles. One is a 45, 45, 90. The other is a 30, 60, 90. And you will notice if I add everything together, right, if I add all those, I get 180 degrees. Same thing if I were to go over here. I'd add them all together, I get 180 degrees. So in a 45, 45, 90 triangle, they have a special relationship, and the relationship looks like this. If I go across from my 45s, right, if I go across from the two legs, these sides are considered x. The side that is the hypotenuse, that is across from the 90, is considered x radical 2. So for example, if I were to say that this side length right here was 10, that means this side length over here would be 10, and this side length over here would be 10 times radical 2. That's it. Okay, so essentially I'm just solving for x, I'm plugging in a number, and we're going to do that with some examples below. The other type of right triangle that has a special relationship is a 30, 60, 90 triangle. So just like this one, I'm going to have a special relationship. If I go across from the 30, which is the shorter leg, right, because it's a smaller number, 30, 60, 90. If I go across from the 30, this side is x. If I go across from the hypotenuse, this one over here is 2x. It says take whatever that number is and double it. The only one that's a little strange is across from the 60, and that is x times radical 3. So for example, if I were to say that x was 10 again, this side length would be 10. This side length would be 2 times 10, which is 20. And this side length would be 10 times radical 3, which is 10 radical 3. Okay, so I've got x radical 3, and 2x. So now we're going to go through. We're going to solve for each missing side using these very special relationships, and we're going to keep our answers in simplest radical forms. So we're going to make sure that our answers have a radical in them as we go through. Okay. So first example, I've got a 45, 90. That must mean this angle over here is a 45. If I go across from the 45s, this side is x, this side is x, and this last side is x radical 2. Well, I already have one number. I've got 10, and the 10 goes along with the x. That means 10, or x is equal to 10. That must mean over here that this other x is also 10, and this side over here must be 10 times radical 2. And I can't reduce it anymore, so I'm done. So I just fill in the blanks here, and I'm finished. Super simple. Okay, so let's try the other example. 45, 90, that must mean this is a 45. So across from the 45s, I've got an x. I've got an x. Over across from the 90, I have x radical 2. So this time it's a little bit different because this time I don't know the x. I know that x times radical 2 is equal to 16. And now I have to solve for x. So I know that x radical 2 equals 16. Well, to get that x all by itself, this is x times radical 2. So the opposite of multiplying is dividing. So I'm going to divide the left by radical 2. I'm going to divide the right by radical 2. Over here, these cancel. I'm left with x equals 16 over radical 2, except it says, remember radical rules. You cannot have a radical in the denominator. That is the number at the bottom of the fraction. I see a radical at the bottom of this fraction. So I'm going to do something called move it up, clean it up. Okay, so I'm going to take this radical, I'm going to move it up. So now I've got 16 and a radical 2 on top. And I'm going to clean up the bottom, which means I'm going to take away the radical sign. So I've just got a 2. Now I don't have a radical at the bottom anymore, and I'm allowed to divide 16 by 2 because they're both outside of the radical. So 16 divided by 2 is 8, and then I keep a radical 2. So I'm left with x equals 8 radical 2. And I go, oh, look, both of these sides are just x's. So this side must be 8 radical 2. This side must be 8 radical 2. Okay, those were my 45 45s. Now I'm going to do, you guessed it, some 30, 60, 90s. Okay. So if this is a 30 and this is a 90, that must mean that this is a 60. Across from the 30 is my x. Across from my 90 is my 2x. And across from my 60 is x radical 3. The first equation that I'm given is that 8 is equal to 2x. Now I'm just going to solve for x. So I divide by 2. Divide by 2. I get x equals 4. Now I just take that 4, I plug it in everywhere I see an x. So this side right here must be a 4. 4 times radical 3 is 4 radical 3. And there we go. I've solved my sides, so I'm just going to plug them in here to my answers. Fabulous. Okay, last one. 60, 90, that must mean that this is a 30. Across from the 30 is my x. Across from the 90 is my 2x. And across from the 60 is my x radical 3. So I don't know what the x value is, but I do know that x radical 3 equals 27. Now this looks very similar to this example 2 that I did up here. I'm going to get the x by itself, so I'm going to divide by radical 3 on both sides. Cancels over here. I've got x equals 27 over radical 3, but I'm not allowed to have a radical at the bottom, so I'm going to move it up and clean it up. So I moved it up, cleaned it up. Now I can actually do 27 divided by 3, right? That just gives me 9, and then I keep my radical 3. Now I'm going to take that, I'm going to plug it in everywhere I see an x. So if I take that, I plug it in over here to this side LM, it's just an x, so this side's 9 radical 3. And I take that x, I plug it in over here, I've got 2 times 9 radical 3. I'm allowed to multiply on the outside. 9 times 2 is 18, and I keep the radical 3. Okay, so there we go. That's our first part with special right triangles, part 1. Okay. Part 2 is some trig functions, and I'm going to assume you will probably remember these from geometry. So again, if I go across from the 90, that's my hypotenuse. If I go across from my reference angle, across from it is the opposite side, and right next to it is the adjacent side. Now, there are 6 basic trig functions. You probably know the 3 right here, sine, cosine, tangent. And your geometry teacher probably taught you SOHCAHTOA, which is just taking these trig functions and writing them as a fraction. So the sine is O divided by H, which is opposite divided by hypotenuse. Hopefully this is coming back to you. Cosine is A over H, which means adjacent divided by hypotenuse. Okay, and then tangent is opposite over adjacent. Now, the 3 that are below are probably the 3 that you have not seen before. These 3 at the bottom are called reciprocal trig functions. They're formed by exchanging the terms in each of the ratios. So reciprocal, right, means you take your numerator and your denominator and they flip each other. So sine and cosecant, these two go together. This is a opposite reciprocal trig function. So the cosecant, instead of being opposite over hypotenuse, is hypotenuse over opposite. Right, so these two match up. Instead of cosine, the reciprocal trig function is something called secant, and I switch these two so it becomes hypotenuse over adjacent. Last one, tangent and cotangent. I switch the ratio of tangent and it becomes adjacent over opposite. So these are called reciprocal trig functions. Okay, now we're going to do an example here. So given the right triangle below, we're going to write the 6 trig functions for the given angle with measure theta. So they're telling me that the reference angle is theta right here. And so I always like to highlight or mark my reference angle in some way so I know where I'm looking from. So the first thing I'm going to do is I'm going to mark my sides. If I go across from the 90, that's my hypotenuse. If I go across from the reference angle, that's my opposite side. And if I go next to my angle, that's the adjacent side. Now, got a little bit of a problem here because I'm only given 2 numbers. I'm given opposite and adjacent. I am not given the hypotenuse, but my hint says, to find unknown side lengths of right triangles, what theorem can you use? Well, that, my friends, is the Pythagorean theorem, right? A squared plus b squared equals c squared. Remember, c is the only one that really matters. C is your hypotenuse. A and B are the 2 legs of my triangle. So here's a leg 16. So I'm going to plug it in for A. Plus my other leg is B, which is 30. Plug it in, and I'm solving for my c squared value. So 16 squared means 16 times 16. That's 256. Plus 30 squared means 30 times 30, that's 900. I almost said 90, whoops. Okay, then I can add these 2 together. I get 1,156. And then now I take the square root, and I get c equals 34. So I figured out that this side over here is 34, which is great because now I can write the 6 trig ratios. Okay, so the first one is sine of theta. We always have to put the angle. Okay, so sine is opposite over hypotenuse. So 16 over 34. Cosine is adjacent over hypotenuse. Adjacent, hypotenuse. And then tangent is opposite over adjacent, so 16 over 30. Okay, now the last 6 are last 3 are really easy because they are just reciprocals. So the cosecant means I just take these 2 and I flip them. I do the hypotenuse over the opposite, so 34 over 16. The secant, again, is this reciprocal, so I flip them, 34 over 30. And then the cotangent is the reciprocal, so it's 30 over 16. So there are my 6 trig functions. Fantastic. Okay. Now, I would keep these numbers right here, these ratios, out in front of you, and I would make sure you always have them out whenever you're doing problems like these, because these are going to help us with every single next problem that we do. So you want to make sure you have those out. I'm going to keep mine out right in front of me as I go through and do the rest of these examples as well. Okay. Example 6. Knowing that, it would help if you could see it. Maybe I can move this a little bit. Okay. There we go. All right. Knowing that the cotangent of theta is 12 over 5, draw a right triangle with angle theta. Find the length of the unknown side and then write the remaining 5 trig ratios. So this is very similar to example number 5 that we just did, except I'm not giving you the picture. You're going to have to draw the picture on your own. Now, cotangent is 12 over 5. If you go back to your ratios that you wrote down, cotangent means adjacent over opposite. So I already know the adjacent and I know the opposite side. That means I'm going to have to figure out what the hypotenuse is. So I'm going to draw myself a picture, a right triangle, put the right angle in. It does not matter where you put theta, okay, but when you label your sides, that's what's going to matter. So if I go across from the 90, that's my hypotenuse. If I go across from theta, that's my opposite. And if I go next to theta, that's my adjacent. So I already know that my adjacent is 12, so I'm going to put 12 in here. And I already know that my opposite is 5, so I'm going to put a 5 over here, which means I have to figure out what the hypotenuse is. So since I'm trying to find an unknown side length of a right triangle, I'm going to use the Pythagorean theorem again. And since I'm trying to figure out what the hypotenuse is, that means I'm going to try to figure out what the c value is. So I'm just going to plug in my numbers. 5 squared plus 12 squared equals c squared. It does not matter, again, which one of these two you do first. The only thing that matters is you're trying to find your c value. So 5 squared is 25. 12 squared is 144. If I add those two together, I get 169. And then I get the c by itself. I'm going to square root both sides. So I end up getting c equals 13. So now I've got this side over here as 13. I've got all 3 of my sides figured out. So now I can write the ratios for all of my trig functions here. Okay, so sine is opposite over hypotenuse. So 5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And then tangent is opposite over adjacent, so 5 over 12. And then to write the other 3, right, they're just reciprocals, so I just flip everything. So cosecant is 13 over 5. The secant is 13 over 12. And the cotangent was already given to me, but it's 12 over 5. And there I've got my 6 trig ratios. Okay, so you can't write your 6 trig ratios unless you have every single side length written or given to you or solved. So you have to make sure you've got all 3 of your side lengths done before you try to write your trig ratios. Okay. Example 7. All right, part A. So triangle MNO is a 45, 45, 90 triangle that has a side length of OM equal to 2. What are the 6 trig ratios for angle N with measure theta? Okay, so let's kind of break this down a little bit. I know it's a 45, 45, 90, so I'm going to put in my 45s into the triangle. Now, I've got my reference angle. It's angle N, right? It's right here with the theta, so I'm going to highlight it. I'm going to mark it as my reference angle. Okay, now, I already know that across from this 45 is a 2, right? If I go across from the 45, that's my x, right? Well, if I go across from the other 45, it's also x, which means it's also a 2. And then if I go across from my 90, I know it's x radical 2. So I plug in the 2, it's 2 radical 2. Look at that, I already have all 3 side lengths written for me. I just have to put them into my ratios here. So across from the 90, this is my hypotenuse. Across from the theta is my opposite. And next to my theta is my adjacent. So now all we're going to do is we're going to write the ratios just like we did the last problem. Okay. So the sign is opposite over hypotenuse. So opposite over hypotenuse. Now I've got a problem here, right? Because I've got a radical at the bottom and you're not allowed to have a radical at the bottom, so I do need to simplify this. Now, I see a 2 and a 2 on the outside of the radicals, right? You are allowed to divide numbers that are on the outside of radicals. 2 divided by 2 is just going to cancel, right? It just becomes a 1. So I've got 1 over radical 2. And then I move it up, clean it up. So it becomes radical 2 over 2. There's my sign. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So 2 over 2 radical 2. Oh, well, look at that. That's the same as the sine. I'm going to skip doing all that work. I know it's radical 2 over 2. All right, last one is the tangent. Can you still see? There we go. Okay. Tangent is going to be opposite over adjacent. Opposite, 2, and adjacent's 2. So 2 over 2 becomes 1. Okay, now I do the other trig functions that are reciprocals, and all I'm going to do is flip them. So cosecant of theta. Now, I'm not going to use this one over here, because if I use this final answer right here, I'm going to have a radical at the bottom, and I don't want that. That's too much work for me. So I'm going to take this first one that I used and flip the first one, okay? So I'm going to rewrite this as 2 radical 2 over 2. Well, I can take these 2's, they cancel. I just get radical 2 for my cosecant. For my secant, guess what is exactly the same as your cosecant, but I'll flip it just to show you. So it's 2 radical 2 over 2. My 2's on the outside cancel. I'm left with just a radical 2. And finally, my cotangent of theta, if I flip 2 over 2, guess what? I get 2 over 2 again. Okay, and there are your 6 trig functions. Those ones were a little tougher just because we had some radicals that we had to deal with, but making sure that we never put a radical at the bottom is what's most important. Okay, we're almost there, dears. All right. Triangle JKL is a 30, 60, 90 with side lengths LK is 4 and the measure of angle J is 30. What are the 6 trig ratios for angle J with measure theta? Okay, so the first thing I'm going to do is I'm going to mark my reference angle. It's right here. Okay, and I always, like I said, highlight it, mark it, do something so you know where you're looking. Across from the 90 is my hypotenuse. Across from my theta is the opposite. And next to my theta is the adjacent. Okay, so I'm told that this angle J is 30. If this is 30 and this is 90, that must mean that this number up here, the K, is 60. Now, if I go across from my theta, this side is x. If I go across from my 90, this side is 2x. And if I go across from my 60, this is x radical 3. Now, you're already given something. X is equal to 4. That must mean that 2x is equal to 2 times 4 is 8. Oh, look at that. It also has that. I just have to plug it in down here for the adjacent side. X radical 3 should really be 4 radical 3. Now I've got all my sides, and all I have to do is write my ratios. So the first one, sine of theta, opposite over hypotenuse. So I've got 4 over 8, which I can reduce to 1/2. There's my first one. Cosine of theta, adjacent over hypotenuse. So adjacent is 4 radical 3 over hypotenuse is 8. Again, I can reduce 4 over 8 to be 1 over 2. So this is radical 3 over 2. I don't really need to put the 1 before it. If you want to put the 1 up there on top, you can. You don't really need it though. Okay, last one. Tangent is opposite over adjacent. So 4 over 4 radical 3. Oops. Woo. Now I'm not allowed to have a radical at the bottom, but first I see 4 and 4 can cancel. I've got to move it up, clean it up. So if I move this up, it's a radical 3 on top, and on clean up the bottom, it's just a positive 3. All right, there's my first 3. Now I've got to do the reciprocals. So cosecant, I just take the 1 and the 2 and they switch places. 2 over 1, which is just a 2. My secant, I've got a couple different options here, but if I've got my 2 radical 3 and I flip it, it becomes 2 over radical 3, and then I need to move it up, clean it up. So it's 2 radical 3 over 3. And I can't reduce, right, the 2 and the 3 here, so they stay just like that. Okay, cotangent, I can flip them, right? 4 radical 3 over 4. The 4's cancel. I'm just left with radical 3. And I am done. So great. Okay, one more example. Now, if you know the sine, cosine, tangent ratio, so if you know the fraction, okay, if you know 2 of the numbers of the fraction, you can use something called the inverse ratio to find the measure of the angle. So the inverse has sine, cosine, tangent. It's got a little -1 next to it. That means it's the inverse. And I'll show you what I mean. Okay. I had a calculator out handy. Would be way better. Okay, well I don't, so we're just gonna have to do this without a calculator. Okay, so here's what you do. I want to figure out what the angle measure is, right, for my first problem. Here's my angle, it's theta. I want to know how much that reference angle is. So I'm going to label the sides that I know. Across from the 90 is my hypotenuse. Across from my angle is the opposite. And next to my angle is the adjacent. So I say to myself, okay, which 2 numbers am I given? I'm given the hypotenuse and I'm given the adjacent. So if I come back and I look at my trig functions, the one that uses adjacent and hypotenuse is the cosine. So I'm going to use cosine for this problem. So I'm going to say the cosine of theta, that's one I don't know, is equal to, cosine is adjacent over hypotenuse, so 38 over 40. So here's what you're going to do. You're going to take 38 and you're going to put 38 divided by 40 into your calculator. Okay, when you do 38 divided by 40 into your calculator, you will get 0.95. Now, keeping that number in your calculator, you're going to push, if you're using your phone, you're going to push the button that says second, and then cosine. And then you're going to push equals. Okay, so second cosine equals, if you push that, it's going to come up as the little cosine with the little -1. And if you do that, you're going to get theta is approximately equal to about 18.2 degrees. So this angle right here is about 18.2 degrees. Okay, let's try it with one more. All right, so here's my theta up top. This is my reference angle. Across from the theta is opposite. Across from the 90 is hypotenuse. Next to the reference is adjacent. So I'm given the adjacent and the opposite. So I come back over here, I say which one is adjacent and opposite? Oh, that would be the tangent. So I'm going to use tangent. Okay. Tangent of theta is opposite over adjacent, 8/14. So you're going to put 8 divided by 14 into your calculator. You're going to get a long decimal. That's about 0.5714. You're going to take that number and push second tan. So it should look like tan to the -1 of that number. When you do that, you'll get theta is approximately equal to 29.7 degrees. So it depends on if you're using a calculator or if you're using your phone. But if you're using your phone, you have to push the second button. If you're using a calculator, you're going to push the shift button instead of the second button. But you should end up seeing it, no matter how you do it, as like cosine -1 of 0.95. You should be able to put that into your calculator like that and get the same answer that I got here. If you don't get the same answer, you're plugging it in incorrectly. Okay, so that is it for our first video. You now have enough information to complete the week 1 video 1 homework, which will be due by Wednesday at 9 a.m. at the latest. If you finish it earlier, you can turn it in earlier. Okay, thanks guys. Have a great day.